For decades, the dominant logic in education has assumed that classroom tests exist primarily to rank students and dole out grades. A student takes an exam, scores well, and gets an A. Another scores poorly and receives a D. But using an assessment merely to dispense a letter grade strips the tool of its actual utility. If classroom assessment doesn't help a teacher do a better job of educating their students, it has no reason to exist. If a test does not have the potential to alter a teacher's instructional trajectory, it is a ritual, not a measurement tool. A functional test is a highly specific information-gathering instrument. Its entire purpose is to collect data that will trigger one of several predefined instructional actions. Consider a scenario where a teacher administers an end-of-unit exam, but plans to move on to the next chapter on Monday, regardless of how the class performs. Whether the students score beautifully or fail miserably, the teacher's next step is identical. That makes the test instructionally useless. In a system of decision-driven assessment, the exact action options are isolated before the test is ever constructed. This requires a specific architectural logic. If a test's results lead to the exact same instructional decision, no matter the outcome, the measurement is illusory. By replacing that flawed model with a binary system, the assessment gains purpose. Imagine the test yields two possible outcomes, a set of excellent performances and a set of poor performances. If the high scores dictate moving to the next unit, while the low scores trigger targeted remedial instruction, the test is now actively informing a decision. The nature of the instructional decision must dictate the entire architecture of the test. To extract usable data, educators have to abandon intuitive grading and engineer their assessments around specific action options. Once the decision options are set, the first step in engineering the test is isolating what needs to be measured. Without a precise target, the assessment will capture pedagogical noise. To isolate that target, we have to separate the journey from the destination. Instruction is the means. It consists of the specific activities, lectures, and exercises a teacher employs to promote learning. Curriculum, on the other hand, represents the sought-for ends. These are the intended changes in a student's skills or knowledge that result from the instruction. Education systems use dozens of overlapping labels for these ends: goals, objectives, standards, benchmarks. To cut through the semantic confusion, we can standardize all of these intended outcomes under a single rigorous label: the curricular aim. Measurement tools must map exclusively to the curricular aim. If you want to know what a student has learned, you measure the ends, not the means. A properly engineered assessment bypasses the instructional activities entirely, anchoring strictly to the intended outcome. Testing a student on the specific mechanics of an in-class activity rather than the overarching skill guarantees invalid data collection. Once the curricular aim is isolated, the next variable to calibrate is the scope of that target, a concept educators refer to as grain size. In the 1960s and 70s, a push for highly precise behavioral objectives led to a massive overcorrection. Teachers were encouraged to break learning down into tiny, hyper-specific instructional goals. This resulted in severe cognitive overload. A single teacher cannot realistically track hundreds of micro-objectives, like monitoring if a student can infer meaning from context clues on Tuesday and conjugate a specific verb on Wednesday. The sheer volume makes the data unusable. The opposite failure is an overly broad, unmeasurable goal. If the aim is for students to understand the true function of the federal government, the target is too ambiguous to assess accurately. The solution to this Goldilocks problem is finding an optimal middle ground that balances instructional manageability with precise measurability. This is the large grain size aim. It is an outcome broad enough to subsume dozens of lesser contributory skills, yet concrete enough that a teacher can clearly determine if a student has achieved it. By organizing instruction around a half-dozen large grain aims rather than 100 micro-objectives, a teacher generates high-signal diagnostic data without being overwhelmed.
There is a hidden trap in selecting large grain aims. An aim is only useful if it can actually be measured by a cohesive assessment. If a teacher sets a broad goal like geometry, but has to build 5 completely separate sets of items to test congruence, similarity, circles, equations, and measurement, the aim is fractured. This is counterfeit coalescence. The data points remain disconnected. The structural ideal is unitary measurability. measuring a student's mastery of several subskills using one consolidated strategy. In an English class, a single original persuasive essay allows a teacher to simultaneously evaluate syntax, spelling, word choice, and argumentation. This unitary task generates a complete profile of the student's abilities. In one fell swoop, the teacher makes a conceptually unified inference about complex mastery. Without unitary measurability, a teacher is left trying to synthesize a divergent, fragmented flock of test scores, which ultimately paralyzes the decision-making process. Once you've built the instrument and collected the data, you face the next structural variable. How do you interpret the resulting score? Historically, education has relied on norm-referenced measurement. This is a relative interpretation. A student's performance is evaluated entirely in relation to the performances of a previous group of test takers. Stating that a student scored in the 90th percentile tells you they beat out 90% of their peers. It acts as a sorting mechanism, useful only in rare fixed quota scenarios where a teacher must select top students for an enrichment program. But relative ranking provides zero diagnostic value. To understand what a student actually knows, you need criterion-referenced measurement. This is an absolute interpretation, hinging entirely on whether a specific skill or body of knowledge has been mastered. This requires distinguishing between the knowledge to be learned, the content standard, and the precise threshold of proficiency expected, the performance standard. On the left, a norm-referenced model continuously shifts, grading students against the curve of their peers. On the right, a criterion-referenced model anchors to a static threshold. A student's success does not depend on anyone else's failure. It is vital not to confuse the terminology. When introduced in the 1960s, a true criterion meant measuring against a clearly defined behavior. It does not mean simply slapping an arbitrary cut score onto a traditional norm-reference test. If a teacher intends to trigger specific remedial instruction based on a test result, they cannot rely on relative comparisons. They must rely exclusively on the absolute data provided by a criterion-referenced architecture. The final architectural choice in designing an assessment is determining exactly how the student will output the requested data. There are two output mechanisms. Selected response tests, like multiple choice or true-false questions, require students to choose from provided alternatives. They are highly efficient for measuring factual recall and discrete knowledge. Constructed response tests demand that students generate an original answer. These outputs take the form of either complex behaviors, like delivering an impromptu speech, or tangible products, like a written essay or a finished piece of woodworking. The format cannot be selected based on convenience. The mechanism must be dictated entirely by the desired score-based inference. If the curricular aim requires evaluating a student's ability to compose a sonnet, relying on a multiple-choice test is psychometrically invalid. You have to have them write the sonnet. Test creation is a rigid engineering sequence. First, isolate the actionable decision, define a large-grain criterion, ensure unitary measurability, and select the precise response format. Built in this exact order, the resulting data funnels straight back to the beginning, triggering the correct instructional action. This is the core of decision-driven assessment. By abandoning normative grading rituals and embracing this structural architecture, educators transform classroom tests from blunt mechanisms of judgment into precise engines for instructional intervention.